So on stage with me, we'll bring up Ratuja Rajwade, Dan McKean, and Zuhair Ahmed. They are all PMs or PMMs at MongoDB and have a very exciting talk for you on internal developer platform and MongoDB Atlas. So please give them a warm welcome.
Thank you, Laura. Hi, everyone. Thank you for attending. Just by a show of hands, who here knows or has heard of an IDP or internal developer platform? Raise your hands if so. Couple people, cool. So, my name is Ratuja. Like Laura said, I'm a product marketing manager for the DevOps tools here at MongoDB. I have the delight of sharing the stage with Dan McKean, who is the product manager for our Kubernetes tools, and Zuhair Ahmed, who is the product manager for some of our infrastructure as code tools like CloudFormation or Terraform. So today, we are going to be talking about something that's been a bit of a hot topic within the developer community. Internal developer platforms, or IDPs, have taken the developer world by storm, simply because they're able to reduce complexity and lower costs while giving developers the autonomy to self-serve. So in this talk, we'll briefly cover what IDPs are and explain why Atlas, MongoDB's developer data platform, is the perfect complement to an IDP. Then I'll pass it over to Dan and Zuhair, who will inform and demo on some of our DevOps integrations, which can be used to incorporate Atlas into your IDP. And then finally, we'll help you in choosing which of the best tools you can use to incorporate Atlas into your IDP. So to kind of illustrate how popular IDPs have become within the last couple years, I want to start off with an anecdote. There is a very popular software company called Leafy Inc. That has a very talented team of developers who all want the same thing, right? They want to deliver value to their customers by creating great products. And so in order to kind of action on this commitment to their customers, the developer team at Leafy really leaned into their DevOps strategy and made the decision to shift left and embrace DevOps. And this helped them have those self-service abilities that gave them autonomy over their infrastructure and how they ran and built applications. But as some of you might have experienced in your own journey around this, they ran into quite a few issues that slowed down and frustrated their developers. They gave their developers pretty free rein to do what they wanted by doing away with ticketing systems or manually provisioning servers. But this resulted not quite in the time savings that they managed would occur, but instead led to a lot of as these developers an end-to-end understanding of their toolchain. This led to something called cognitive load. Cognitive load is exactly what it sounds like. It's just the amount of thinking and processing that is required in order to do a task. And so, of course, with this cognitive load increase, it slowed down the productivity and ultimately the output in this developer team. With great power comes great responsibility, and it ended up being that these developers had way too much responsibility, which ended up creating a lot of compliance and security issues across the organization. Improper data auditing or general permissions that these developers, compliance issues, and overhead costs, ultimately sort of threatening business operations and the developer organization as a whole in terms of productivity and output. It's clear that these developers needed a holistic solution in order to do their jobs well. Uh-oh. Sorry about that. So after some deliberation, they decided that including and incorporating an internal developer platform, or an IDP, within their developer organization would end up creating a lot more efficiency, not only for their developers, for the business as a whole. The internal developer platform, or an IDP, for those of you who don't know, is a connected system, a connected system of tools and processes that enable developers to run faster by creating more self-service, reducing cognitive load and complexity within the developer environment. So when the IDP was implemented, they were able to abstract away a lot of the complexity that comes from self-managing your toolchain, thus reducing cognitive load. The IDP also standardized workflows, which enabled easier collaboration across the developer organization and enabled greater scaling ability as new developers came onto the team. The introduction of consistent tooling and processes as a result of the IDP being included ended up creating more self-service across the developer organization. And because the IDP was developed separately from the applications themselves, developers were able to focus on the tasks at hand and have a different team within the developer organization managing their IDP. The reduction of rights and permissions across the toolchain helped developers reduce any sort of security exposure that the business might have been exposed to. And most importantly, the developers were able to focus on their jobs, leading to happier and more engaged developers. So Leafy came up with the framework for their IDP. The beauty of an IDP is that it's bespoke. So it's made and tailored for a developer team based on their needs. But that's not to say that Leafy's IDP didn't include some common tools that you might see across many IDPs. So one of the most critical choices that they ended up having to make was incorporating a data layer. I'm sure you can imagine where this is going. So developers will tell us that working with data is one of the most difficult aspects of their jobs. In order to address this, they might incorporate a single source data tool like a stream processor or a transactional database. But this ends up creating a pretty fragmented developer experience. And so to remedy that, developers will add in a lot more tools that they think can address those use cases they might run into, inevitably creating infrastructure sprawl. So in order to make developers' lives easier, it's critical that we make it easy to work with data, right? And so ultimately, when Leafy was deciding on the data layer that would be the most optimal for their internal developer platform, MongoDB Atlas, MongoDB's developer data platform, was a natural fit for their IDP. Because Atlas is fully managed, it abstracts away any of the complexities that come from managing your database. Developers on Leafy's team were also assured that their data layer stayed up and running, as MongoDB Atlas is distributed across 100+ regions and all major cloud providers. MongoDB also enables you to confidently run your most important database operations, as it has built-in automation and resource and workload optimization that smooths and streamlines all of your data operations in general. And finally, our integrated services that are a part of MongoDB make it a full suite of developer data tools that enables you to build and underpin best-in-class applications for your customers. And so rather than having to choose between data tools, as we saw previously with other use cases, MongoDB enabled these teams to address a full breadth of use cases when it came to their data. And that's because MongoDB Atlas is a step beyond a traditional database, right? It enables developers and organizations to drive innovation by providing them a unified interface that helps them address a multitude of different data use cases, such as analytics or search, app services, AI, or serverless, essentially enabling them to create and build applications at scale. So now it was time for Leafy to implement their IDP Atlas into their IDP. Most IDPs are built and stitched together via APIs, and thankfully Atlas has one of those, the MongoDB Atlas Admin API. The Atlas Admin API gives developers a RESTful interface for programmatically interacting with Atlas. That means that developers are able to work with Atlas in a workflow and tooling that is familiar and native to them. And so, given that we want to meet developers where they're at, MongoDB Atlas's Admin API has a multitude of tools that are built on top of it that enable developers themselves to work with Atlas in a way that is native to them. For example, if a team is much more comfortable working with a Kubernetes workflow, the Atlas Kubernetes Operator is a great option for developers to manage and build with Atlas in Kubernetes the same way they would any other application in Kubernetes. For teams that are more comfortable working out of Terraform or CloudFormation or any of their respective CDKs, this is a great option for teams who want to spin up and provision Atlas projects and resources in the cloud environment of their choice. And finally, for teams who are more comfortable scripting out commands, the Atlas CLI is a great and easy option for teams to be able to run and manage their Atlas projects and resources through 2 simple commands. As I said before, all of these are built on the Atlas Admin API, and developers have the choice to kind of work with the right downstream tool for them. I'm going to pass it off to Dan, who will speak a little more in depth about how we work with Kubernetes. Dan?
Thank you very much. Cool. So yeah, as Ratuja mentioned, at MongoDB we offer the Atlas Kubernetes Operator for integrating Atlas into a Kubernetes-based IDP. We're going to dig into that now. You've got a good understanding of IDPs and Atlas's brilliant fit into IDPs. So Kubernetes has become a very common foundational layer for many IDPs, thanks to the benefits of using containers, combined with the huge automation and flexibility that Kubernetes itself offers. One of the most significant Kubernetes developments has been the support for Kubernetes operators. So Kubernetes uses its built-in control plane that manages all aspects of the cluster and powers all of the intelligent automation that happens within. An operator is an extension to that built-in control plane. Extends Kubernetes to support custom logic for a specific application. In this case is obviously Atlas. Operators make use of custom resource definitions that define new types of Kubernetes resources. And these custom resources can then be managed in the same way as any other Kubernetes resources, meaning they're often defined as YAML in a Git repo and applied into Kubernetes through a GitOps workflow. Operators can handle more than just the infrastructure because they have application-specific expertise and logic built in. An operator can handle more advanced application changes like rolling upgrades or use of features that are unique to that application. Operators can manage services running within Kubernetes, and we have an enterprise operator that does that for our enterprise advanced offering, but they can also manage external services. So in this case, we're talking about Atlas. The MongoDB Atlas operator is built to simplify the integration of Atlas into a Kubernetes IDP. So the Atlas services themselves run in one of the 3 hyperscalers, but with the operator, you can still leverage declarative configuration in a GitOps workflow to configure Atlas via Kubernetes. This allows the developers to use the same tooling and processes. As I mentioned, that's quite often a Git repository and continuous deployment tooling like Argo CD to achieve a GitOps. This allows the users and the company to manage their configuration as code in their repository alongside the configuration for their applications that actually run in Kubernetes. So it's perfect for an IDP and it allows reuse of the tooling. From there, the Atlas operator picks up the configuration in your custom resources and applies it into Atlas through the Atlas admin API. So the users themselves need minimal onboarding, and the options that they have available to them are guided through the custom resources that we offer. So it ties back into what Ratuja mentioned about trying to reduce cognitive load, and that being a big motivation behind IDPs in general. This makes it fantastic for developer self-service. Absolutely. And the operator allows the developers to reuse their existing processes, like I mentioned, rather than having to actually interact directly with a new API. And the IDP is often centrally managed, as is the operator. And it's quite common for our customers to give out templates for Atlas resources that the developers can use, which makes it really, really easy to get started just by copying a template into a repo and customizing it. As with other operators, the Atlas operator helps configuration drift, and that's due to the fact that operators in general do periodic reconciliations. So they check the version that you've deployed into Kubernetes, which is the source of truth, and they check reality, and if there's any differences, then they'll make the changes. This helps ensure that all changes that are made and that stick are managed in the right way and following your processes and your approval processes. The Atlas operator itself supports any Computer Foundation certified flavor of Kubernetes, which includes the Kubernetes offerings from Azure, AWS, and the operator's been in development now for about 3 years. It's been in use by customers for most of that time, and in general availability for over 2 years. So now we've reached the first of our demos in this talk, and this one's focused, unsurprisingly, on Kubernetes and the Atlas operator. And I'm going to show you how to use it with common IDP tooling. So effectively, that means leveraging Atlas, as Ratuja suggested, as a database as a service in an IDP, in this case, Kubernetes-based. Not only does it fit in superbly with Kubernetes-based applications, but as you mentioned, Atlas's fully managed service makes it much, much easier than trying to self-host. I'm going to begin by showing how to install the operator, and then we're going to use it to create a deployment manually so that we can see a comparison. Then we're going to move on to leveraging GitOps and Argo CD to achieve a GitOps workflow. This will make it really, really easy to see how easy it is for developers to manage Atlas through declarative configuration within their existing repository and using very, very common tooling to Kubernetes. It also offers a highly automated and standardized workflow, which in turn cuts down on the expertise and the permissions that individuals need within Kubernetes, which is great. And then finally, I'm going to show you how easy it is to actually connect an application using a Kubernetes secret that the operator automatically creates for every database user that's managed through the operator. So an operator in general can be installed in a number of different ways. It can be done using kubectl, Helm charts, or automation scripts. But in this case, we're actually going to leverage the MongoDB Atlas CLI, which we've added functionality to simplify the installation of the operator, as we'll see in a second. So by installing the operator through the Atlas CLI, not only does the operator actually get installed in the cluster that you're currently connected to with kubectl, but all the necessary setup happens, in particular creating the new API keys in Atlas that you need and creating the corresponding secrets in Kubernetes for the operator to actually connect to Atlas. So we can see there that I've installed the operator and the pod is getting started. In the Atlas UI, we can actually see that the API keys have been created. And now if we look at the Kubernetes secrets, we'll see that we've had a secret automatically created for the operator's API key. So now that the operator is actually installed, we're going to create our first project. It's really simply defined within a YAML file. And as I mentioned, in this case, we're going to use kubectl apply to actually apply it into Kubernetes. From there, the Atlas operator will actually pick up the newly created project resource, and it will create that resource in Atlas by calling the Atlas admin API. So there we can see the project created. Now we're going to deploy our first cluster, and again, it's relatively simple YAML file. We're going to define the cluster, including the instance size down the bottom, the provider, and the region that we want it to run in. There's a whole host of other configuration options, but those are kind of the basics to get started. And then again, just for comparison, for the next step, where we show you a GitOps workflow, we're going to apply it manually. From there, again, the Atlas operator will pick it up and call the API, and the cluster will get created in Atlas. So if we click into the project, we'll see the cluster is currently being created. So now we're going to move on to the better way of integrating into a platform like this, an IDP. We're going to look at a GitOps workflow using Argo CD. So installing Argo CD involves basically creating another operator in Kubernetes. So we're going to create a namespace just to keep this segregated. And then we're going to run a single installation script that takes kind of one command and a few seconds. And we'll be able to see that the Argo CD operator pods have started running in the Argo namespace with this next command. Now we've got that running, we can actually create an Argo application. So we're defining the Git repository that Argo CD will be watching, and we'll find that our new IAC files. And we're defining the IAC files and where they're living in the Git repo, as well as the destination Kubernetes cluster to actually apply those to. So now if we go over into the Argo CD UI, we'll be able to see the database as a service object. So that's basically the definition for our GitOps workflow. So now we can actually create a project. It's almost identical apart from a slightly different name of GitOps, defining much the same thing. Only this time, instead of using kubectl apply, we're going to do a simple git push to our repository. And as we're able to see in the Argo CD UI, our Argo application has already picked up the changes at the project custom resource in Kubernetes. So now if we flick over to Kubernetes, we'll be able to see that resource created there. And in the background, as it happened before, the Atlas operator will have picked up this new custom resource in Kubernetes and automated the creation of a second project there. There's our GitOps project. Now, we can use the same or much the same cluster definition as before, but again, it's a GitOps cluster this time, defining much the same thing. And again, it's another Git push, and all the magic happens again. We'll be able to see in Argo CD UI that the changes have been picked up, and Argo CD has already pushed that custom resource into Kubernetes. And again, the operator, if we click into here, will have initiated the project creation. That's how simple it is to get started actually deploying and creating a new database through a GitOps workflow. But let's see just quickly how easy it is to connect applications to those in a Kubernetes native way. We'll be using a new custom resource called Atlas Database User. Since each Atlas database user is just another file in your repository pushed in through your GitOps workflow, the operator makes managing them as easy as it does deployments. So I've already created the user password. That's a secret containing the password that we're going to use for this user. And here we're defining an Atlas database user. We're specifying the username, specifying the link to the secret for the password. And again, we can just push to the Git repository. Argo CD will automatically pick that up and apply that into Kubernetes. The operator will then pick that up and create that over in Atlas. So when a user's created, we actually create a second secret. It's named for the project cluster username combination. And the secret contains all the connection information, including the connection string that you can see there, that's needed to actually connect to our deployment. So for this last part, just to demonstrate the connection, we're going to create a really simple Kubernetes deployment. We're going to use the Mongo image, and we're going to use Mongo shell to actually pull in that connection string as an environment variable, and we're going to use it to connect. So in this case, we're not going to use the GitOps workflow. We're just going to quickly apply that and create that simple deployment. If we get the name of the pods, and then we get the logs, we should be able to see a successful prompt that shows a successful connection to our database. So there we've got the pod name, and if we pull the Kubernetes logs for that pod, we will be able to see a successful connection prompt there at the bottom, showing just how easy it is through this kind of workflow to not only set the workflow up, but also create a cluster, a project, a user, and actually get an application connected to your database in a Kubernetes environment. So as this was the end of this demo, and there's more to come, you may have expected some fireworks, but the good news is that when you're managing infrastructure like this, not having fireworks is actually a really good thing. So that's it for our look at Kubernetes in the Atlas operator. And now I'm going to hand over to Zuhair to look at some of our other infrastructure as code integrations.
Thank you, Dan. So at MongoDB, we like to believe that developers come first. And not everyone will have a good mindset or good understanding of every single DevOps tool out there. It seems like every single day a new one is created, a new one's published. So in addition to the Kubernetes Atlas operator, we also have the MongoDB Atlas Terraform Provider, the CloudFormation resources, and the CDKs, which I'll be doing a quick run through today. So first up, maybe just quick raise of hands. How many folks have actually used Terraform before in any capacity? Awesome. Yeah, no, this is great. I mean, guys would love to know that our MongoDB Atlas Terraform provider is actually the #1 most used a Terraform provider in the database category. We're also in the top 10 overall, which we're incredibly proud of. Just yesterday, we crossed over the 25 million downloads mark which is super exciting to see. So ever since we first launched in 2019, it's been a big journey to get here. So really proud of the team to getting us there. Secondly, we launched the CloudFormation resources a few years back, and we went GA last year. The CloudFormation resources are an AWS native approach to using infrastructure as code. 40+ resources are maintained today, and they're great for organizations who are AWS native and looking for a first-party solution. And then most recently, we launched our integrations with the CDK, which is really exciting to see. So there's CDK for CloudFormation and CDK for Terraform. With CDK, you get the benefit of using your native programming language of choice to deploy infrastructure as code. So whether you're proficient in JavaScript, Go, Python, C#, you get to stay in the developer mindset. You get to stay in that focus zone, and you get to deploy infrastructure resources, which is really cool and really exciting. Given that CDK is our most recent integration, wanted to just double-click there. If you look at a very simple, basic MongoDB Atlas deployment in CloudFormation, for example, you typically will need at least 4 resources at a minimum. You're going to need MongoDB Atlas project, cluster, database user, and project IP access list. So before this demo, we actually counted. That's about 300 lines of JSON that you and your organization will have to maintain. With our new CDK L3 Atlas Basic resource, that actually drops down to about 100 lines of the programming language of your choice, in this case, TypeScript, which is basically 200 fewer lines of code to maintain, 200 fewer lines of headaches, 200 fewer lines of less bug issues and maintenance. And this is a relatively trivial example. You can understand how your code base begins to expand, that this variance might even get bigger and bigger and bigger. And going back to what both Rituja and Dan were mentioning, helps reduce the cognitive load for you and your team. So there's a few customer success stories that I wanted to share. The first is from Okta, who many of you folks have probably heard, based out of the Bay Area. They're a user of our Terraform Atlas Provider. MongoDB Atlas takes administration away from my team, and our developers are much happier. It's great to have happy developers. And then Otter Group, which is a German retailer. We opted for the MongoDB Atlas CloudFormation resources because they're easy to use and help to scale up to meet the needs of our business. So 2 very different organizations, 2 very different industries, and 2 organizations using 2 different of our tools. One is using Terraform, one is using CloudFormation. Both are successful in MongoDB Atlas. Again, just going back to the whole message that, at MongoDB Atlas, we work backwards from whichever tool, whichever DevOps framework that you work or that are used to, and we're looking for ultimately success on Atlas versus, regardless of any other tool that makes sense for your organization. So let's jump in a little bit deeper to our quick demo with the CDK and the Cloud Development Kit. As folks might have used CDK in the past, setup is really easy. It's intentionally designed that way. First, you're going to make sure to set up a MongoDB Atlas account if you haven't already. If you're familiar with the AWS Marketplace, we have an AWS Marketplace listing. 2, you're going to set up your programmatic API keys. And then 3, you're going to install the AWS and Atlas CLIs or the command line interfaces. And that's really much it for setup steps. We're really glad we got it down to such minimum amounts. In terms of the actual deployment, I just wanted to really just flash each of these 7 steps on stage for you guys today. We'll be going through each one of these, but you'll understand that going from an empty terminal to what we'll have at the very end, which is a fully deployed MongoDB Atlas cluster, can be done with just these 7 commands. So pretty excited to show you guys all that for you today. Okay, so this is just basically an empty directory in VS Code, and first line straight from the AWS CDK tutorial. npm install -g or global the AWS CDK. This installs the CDK in your machine if you haven't already done so before. And what's really exciting about that is that that's always continuously being upgraded and maintained by AWS. So making sure to do that gives you the latest and greatest version. Next, we're going to bootstrap. And you're going to make sure to use your particular AWS account and in the region that you want to deploy to. Again, everything within AWS is region specific, so you'll have the flexibility and the opinion to choose whichever works best for your organization. So that's 2 steps down. We're going to clear up, and this is step 3. We are going to CDK init install the language of our choice, which in this demo we're going to be using everyone's favorite, TypeScript. Of course, you can choose whichever language you want with the MongoDB Atlas resources for CDK. All CDK languages I'm proud of. And with the init command for TypeScript, you see that it will create your different file structure, which is really exciting. And then one library that you have to install, npm install awcdk-resources-MongoDB Atlas. This will give you access to those 40+ MongoDB Atlas resources, which I mentioned earlier. And once you have this, you'll be able to keep track of all the different changes and modifications and updates that we're continuously pushing out for all our developers. Next, you'll see a bunch of boilerplate code that's already populated within the CDK. What I'm doing now is that I'm actually grabbing a quick demo, atlasbasic.ts, from our GitHub repo, and I'm pasting it within our lib directory. Track of the actual file name, test1-stack.ts. We're going to be pasting this demo inside this the lib directory, and we're going to be changing the default name to whatever your directory is, wherever you actually saved it. So this is going to be, of course, that test stack. Okay. Next step is the CDK diff, which is actually my favorite command. Nothing is actually deployed here, but this is very similar to if you are familiar with the Terraform plan. So it gives you a quick summary of all the different resource additions, modifications, and deletions that may occur. And with this CDK diff, you'll see that 4 resources are being created under the hood. And again, we didn't actually provision or call those 4 resources explicitly. By using the CDK L3, all those are being abstracted away for you, which is really exciting. So today we'll be creating that project, cluster, database user, and that project IP access list. If all that looks good to you, then we can move on to CDK deploy. And because this is a higher level CDK L3 resource, we're actually going to be passing in just 2 parameters. The Atlas organizational ID and the IP address for which you want your IP access list to be available to, and that's it. So it's really cool how we got it down to such a minimal amount of commands. Once you're comfortable with the deploy statements, you hit enter, and you'll see a nice, healthy green status bar, which lets you know that the deployment is ongoing and in progress. The other cool thing about CDK is that it is an abstraction built on top of either AWS CloudFormation or HashiCorp Terraform. So at any point, you can always go back and look at the underlying CloudFormation templates, which is really cool, to actually see what's going on under the hood. And I find it really helpful for debugging or tracking purposes. So you'll see here is actually the CloudFormation terminal. Within the AWS Management Console. And by going into the CloudFormation stack, we can actually see our events history of what is actually happening from our terminal command that we deployed. So remember those 4 resources? You'll see that those are actually being deployed or actually have been deployed right now. So you'll see the project, you'll see the IP access list, and you'll see the database user. By going into our resources tab, you'll actually see that the only one remaining is that Atlas cluster. The other 3 have been successfully deployed, which is awesome and really great to see. Just keep in mind that when deploying new Atlas clusters, typically we typically guide for like 7 to 10 minutes. But once we jump forth into the Atlas UI, which is what you see on the screen over here, the user interface, you can actually double check what we saw in CloudFormation. So looking at the database access tab, you can actually see that the database user has been created successfully. By looking at the network access tab, you can actually see that the IP access list that we added has been added successfully. And again, this is just that one command that we had passing in that org ID and the IP access list. All this is being created for you under the hood. And then lastly, the Atlas cluster. And you'll see the dotted lines in the Atlas UI, letting you know that the cluster is currently being created. Fast forwarding a little bit, now the cluster has been created, which is awesome. You'll see all the resources have been deployed. You might ask, well, hey Zuhair, how do I actually connect to this cluster? Well, great. There's a nice, easy connect button, and you'll get your connection string, which is basically all that you need to get started and start building your next great app with MongoDB Atlas on our new integrations with CDK. That was a quick demo. and audio listeners, if you are more of a blog post reader like myself, you want this more in written feedback, all the commands are displayed here on this blog post. This is a new blog post that we did in partnership with AWS, highlighting our partnership with the AWS CDK and serverless. So if you are interested in learning a little bit more about compute and any of the API serverless offerings from AWS, it's a good one to check out. And with that, I'll pass it back to Rituja.
Thank you both. So yeah, as you guys just heard from Dan and Zuhair, our integrations with the Kubernetes operators, Terraform, CloudFormation, and the respective CDKs can help make Atlas a pretty powerful data layer within your IDP. And that's really for all the same reasons that someone would want an IDP in the first place, right? MongoDB enables teams to have a high level of automation within their data operations, whether that's through provisioning a CI/CD pipeline for data services, or scaling data operations. Atlas also leverages those well-established DevOps practices to plug into your IDP by giving developers a unified platform that enables them to have full autonomy over their data operations. And this ends up giving them an optimized developer experience. And then finally, Atlas does what all great IDPs do, and that's lower cognitive load and reduce complexity by providing a fully managed cloud service developer data platform. So in thinking about which integration that these two gentlemen talked about today, when you want to use it to connect Atlas into your IDP, you've got plenty of choices with great benefits. Let's say you are more bought into a Kubernetes story. As Dan went over in his demo, the Atlas Kubernetes Operator is a great option for your team. It allows you to manage MongoDB Atlas in Kubernetes, again, the same way that you would any other integration or application within Kubernetes. It's Kubernetes native, so you're able to reuse all of the same tooling and processes that you would, such as a kubectl command. And similar to other Kubernetes resources, you can manage Atlas configuration as declarative infrastructure as code files, as Dan mentioned, or configuration definitions. And then finally, the operator will provide a highly simplified management of Atlas through a simple interface, again, that helps combat infrastructure drift. Through the raise of hands that we saw in the audience, it looks like Terraform is a pretty popular integration. So if your team is into using Terraform, CloudFormation, or the respective CDKs, these are great tools that you can use to incorporate Atlas into your IDP. They simplify the management of Atlas, and they encourage reproducibility across different cloud environments. And they're also supported by a multitude of different communities and ecosystems that enables you to have access to a lot of documentation, modules, etc., that can help accelerate development and deployment. And again, in the spirit of meeting developers where we're at, we're really pleased to announce that all of these integrations have support for some features that you heard about today in Dave and Zahir's keynote, the first being stream processing, and then search nodes for vector search and Atlas search. And so to tie all of it together, MongoDB Atlas could be the best option as the data layer within your IDP, just for its ability to scale, reduce complexity and cognitive load. And through the various integrations that are built off of the admin API, you can use those tools to easily integrate Atlas within your IDP. So if you want to learn more about any of the integrations that we talked about today, feel free to scan the QR code or go to the links below them. I'll leave this up for a minute. And cool. And thank you. Once again, I'm Rituja.